In this lesson, we are solving algebraic equations involving powers. Remember, to solve an equation, we've got the output number, we need to find the input number. So how can we solve this equation? 5 to the power of x plus 1 is 125. Note that the unknown number is now part of the exponent. Hi Draco, so let's revise. What is a power? 3 to the power of 2 is a power. It means 3 is multiplied by itself twice and the answer is 9. So within a power, the 3 is the base. That's the number that is being multiplied by itself. And the 2 is the exponent. That's the number that tells us how many times the base must be multiplied by itself. So solving equations with powers means to find the value of the variable which makes the equation true. Well done, Draco. So how many factors of 7 is 4 factors of 7? So this is easy. If two powers with the same bases are equal, then the exponents must be equal. There are the two powers, their bases are the same, so x is equal to 2. That makes sense. Let's look at example 1. 6 to the power of x is 216. So if we can get 216, write it as a power with a base 6, then we can say the exponents are equal. But how can we do that without a calculator? Let's use prime factorization. Do you remember in grade 8? So we take the 216 and we divide it by the smallest prime number we can. 2 goes into 216 108 times. We continue until we cannot use 2 anymore. 2 goes into 108 54 times. 2 goes into 54 27 times. Now we use the next prime number, which is 3. 3 goes into 27 9 times. 3 goes into 9 3 times. And 3 goes into 3 once. Now we've got our prime factors. So how can we use that? If we use the commutative property, we can see we've got a 2 times 3, a 2 times 3, and a 2 times 3, which is 6 times 6 times 6, which means 216 is 6 to the power of 3. Amazing, and that's what we want. So now that the bases are the same, we can say x is equal to 3. And you can check 6 to the power of 3 is 216. We have checked our answer. Example 2. We've leveled up. So now our exponent is an expression. Whoa, we'll follow the same pattern. We need to change the number of 64 to a number with a base of 2. Now you should know by now that 64 is 2 to the power of 6. So now that the bases are the same, we can say the exponents must be the same. But we don't want x plus 1, we only want x. So we use the additive inverse of plus 1. And we subtract 1 from both sides. So x is 5. Let's check our answer. In our original question, the x plus 1 will then be 6, and 2 to the power of 6 is 64. Well, this is easy. In example 3, okay, here's a tricky one. So we've got 10 to the power of x is a decimal. Now we know that 0,001 is 1,000th, right? It's a very small number between 0 and 1. And 1,000th can be written as 10 to the power of negative 3. So now that the base numbers are the same, we can say x is negative 3. Let's test our answer. 10 to the power of negative 3 is 1,000th and it's 0,001. Example 4. 4 to the power of negative x is 1/16. We don't always have to use prime numbers, as we just need to get the base number the same. So we can see 16 can be written as 4 squared, am I right? But we cannot equalize the exponents yet. So we have to change 1 over 4 squared to a 4 sum. But we know that 1 over 4 squared means the same as 4 to the power of negative 2. So then negative x is negative 2, but we don't want negative x. So we have to divide by negative 1, so x is 2. Let's check. 4, and then there's already a minus, but x is 2. So 4 to the power of negative 2 is 1/16. So let's summarize. To solve equations with powers, we change the side that does not contain the unknown to the exponential form with the same base. Since the bases are the same, and since the powers are the same, the exponents must be the same. So guys, just get those bases the same. Now I need to get practicing and to get even stronger. Why do we have to know how to solve equations? To solve life problems, of course.